Okay, let's do some scientific notation. All right, if I want to convert to a decimal notation, remember if my exponent is positive, that means it's a large number, and I move my decimal to the right. So this is going to be 7, 6, and I'm going to move it 1, 2, 3 places to the right, so I have to fill in with 2 zeros, and I get 7,600. Okay, if I want it in scientific notation, remember there's one digit to the left, so I know I'm going to write it as 5.96 times 10 to some power. Since this is smaller than 1, I know it's going to be negative, and I move the decimal 2 places to the right. Whoops, it goes here. So 10 to the negative 2. Okay, so I'm going to write my answer in scientific notation here. So I'm actually going to do 2.75 times 4.20 times 10 to the third times 10 to the negative 5. So let's see, this gives me 11.55 times 10 to the negative 2. But this is not scientific notation, so I have to take this and move this one place to the left, so that is 1.155 times 10 to the first times 10 to the negative 2. Then I'm going to multiply these, so it's 1.155 times 10, 1 plus negative 2 is negative 1. Okay, so for here I'm going to do 1.6 divided by 6.4 times 10 to the negative 2 over 10 to the negative 7, which becomes 0.25 times 10. Negative 2 minus negative 7 gives me to the 5th. But again, this is not scientific notation yet, so I have to write this as 2.5 times 10 to the negative 1 times 10 to the 5th, which gives me 2.5 times 10. I add these exponents to the 4th. Okay, factor completely. Boy, we have to remember all our rules on this. The very first thing I look for always is a GCF. Okay, so if I have this, I see I have a GCF of 3. So that becomes 3 times x squared plus 8x plus 16. Now, I recognize this is a perfect square. However, if you don't, then just remember you're looking for two numbers whose multiply to equal 16 and add to equal 8. So this becomes 3 times x squared plus 4x plus 4x plus 16. So if I group these now, this becomes x times x plus 4 times x plus 4, which becomes x plus 4 times x plus 4, and I remember to bring down my GCF as part of my answer. And there you go. Okay, here I have 4 terms. There is nothing in common to all 4 of them. So I can just go ahead and group. I have a plus sign in between, so I'm good. The GCF here is x, and I'm left with x minus 2y. The GCF here is 1. I'm left with x minus 2y. I have a common binomial factor of x minus 2y, and my GCFs are x plus 1. Okay, C, I don't have a greatest common factor. They don't all have an x, and this one is not divisible by 2. So 4 terms I'm ready to group. Okay, but I have to remember here that it has to have a plus sign in between, so the negative sign goes with the 8. Greatest common factor here, is x squared, and I'm left with x plus 2. I want to factor out that negative, and the GCF is 4. I'm sorry, this is 2x plus 1. Let's do that. So this is x squared times 2x plus 1 minus 4 times 2x plus 1. I now have a common binomial factor of 2x plus 1. I'm left with x squared minus 4. Now it says factored completely. I've done everything correct, but I haven't finished. This is a difference of squares. This becomes x plus 2 times x minus 2 because it is x to the second minus 2 to the second. And then I have to include the 2x plus 1. So there's my final answer. Okay. All right, 2 terms. Look for a GCF. I have one. The GCF is 5x. And I'm left with x squared minus 9. This is, again, a difference of squares because this is x to the second minus 3 to the second. So this becomes x plus 3 times x minus 3. Include my 5x in my final answer. And there we go. Okay, E. There is a greatest common factor of x. So I can factor out an x, and I'm left with 4x squared plus 23x minus 6. Okay, so now I'm going to have to factor this. Since I have a leading coefficient other than 1, I'm going to have to multiply these. So I'm looking for 2 numbers whose product is negative 24 and whose sum is 23. And they are 24 and negative 1. So I'm going to just put this to include in my final answer. So this becomes 4x squared plus 24x minus x minus 6. I can group this now, remembering that it has to be plus. My greatest common factor here is 4x. And I'm left with x plus 6. Have to figure out that negative, x plus 6. I now have a common binomial factor of x plus 6. My GCFs are 4x minus 1. Include my x in my final answer. And there you have it. Okay, 9x squared plus 16. There's no GCF, so the only possibility is a difference of squares. This is a sum of squares, so it is not factorable, which we call prime. Okay, 2x to the third. Okay, they've all got x's. They're all divisible by 2. So I can factor out a greatest common factor of 2x times x squared minus 6x plus 8. So since my leading coefficient is 1, I'm looking for two numbers whose product is 8 and whose sum is negative 6. They are negative 4 and negative 2. So this factors into x minus 4, x minus 2, include the 2x, and there's my final answer. Okay, 3x squared minus 11x minus 20. There's no GCF. So I'm going to have to multiply this, since this leading coefficient is not 1. So I'm looking for two numbers whose product is negative 60 and whose sum is negative 11. And they are negative 15 and 4. So this becomes 3x squared minus 15x plus 4x minus 20. If I group them, I've got a plus sign in between, so I'm golden. So this gives me 3x times x minus 5 plus 4 times x minus 5, which gives me x minus 5 times 3x plus 4. Okay, solving for a variable. That means whatever I'm solved for, I have to get that by itself. So I have to get the b by itself. Okay, so what I'm going to do first is I'm going to multiply both sides times 2 over 1. So that gives me 2a is equal to bh. I'm almost there. I've got to get the b by itself, so that means I'm going to divide by h. So this becomes 2a over h is equal to b. And there's my final answer. Okay, if I want to solve for x, I have to get rid of the y, I have to get rid of the r. I'm going to get rid of the y first by adding y to both sides. So that gives me rx is equal to t plus y. And I'm going to divide both sides by r. So I get that x is equal to t plus y over r. And that's my answer. Okay, if I want to solve for q, the first thing I'm going to do is multiply both sides times 2. So that gives me 2q is equal to p minus q. Okay, then I'm going to subtract p from both sides. So that gives me 2q minus p is equal to little q. Oops, negative q. Now I have to divide everything by negative 1. So that gives me negative 2q plus p is equal to big Q, little q, excuse me. And there's my final answer. Okay, this is a good place to stop.